In our last module, I went through an example of a piece of code that had some room for improvement, and wanted to follow that up in this module with a similar piece of code that is significantly better in terms of its use of function M files and making the code more modular and more readable. So again, this the processing that's going on in the code is not terribly important for this particular class, but suffice it to say that similar processing is going on in this code as with regards to the previous code that we talked about in the other screencast. And if you take a glance over it, you can see that it's still pretty long. It's a main routine. It's still pretty long. There may have been some additional places where it could have been streamlined a bit. However, what you see is that it's at least 50% comments. So yes, it's long, but part of the reason that it's a bit long is because there's such generous amounts of comments. Virtually every line that's being executed has a comment line or two that is explaining what the piece of code is doing. And if you've never had the experience of picking up a piece of code that you've written a year or two earlier and looking at it and realizing you have no idea what you wrote, then just hang in there. The time will come that either you will read your own old code or you'll read somebody else's old code. And if it is not documented and not commented properly, it's almost worse than having to start from scratch. So, lots of comments here. All the lines are being commented. But in addition to that, what we see is that there's lots of usage of user-defined function M files. So, for example, inside this for loop, we have a case where satellite positions are being computed. That's a user-defined M file. Clock corrections are being computed. Again, a user-defined M file. Coordinate conversion being performed. Again, a user-defined M file. And other examples. This is a GPS example, so ionospheric delay correction is being computed in a user-defined M file. Tropospheric delay correction is being computed in a user-defined M file. Adjustment of satellite position coordinates to account for Earth rotation, again, a user-defined M file. And then later on, actually computing the position solution based on the GPS measurements, again, a user-defined M file. Now, obviously, all of those things could have been done within the main routine, and it would have made it extremely long and extremely unreadable. But by taking advantage of function M files, then the driver routine is kept to a minimum length, and each of these functions can be developed, tested, debugged, and then left alone so that they can be called upon anytime that's necessary. And of course, that's the strength of the modular approach to software development.